So here, it's pi over 1/3, which is 3 pi, okay? Asymptotes, we're going to take 1 over 3x, and we're going to bound them. So, now let's just check for a minute. This is going from negative 3 pi over 2, negative 1.5 to positive 1.5. That distance is 3 pi, which is consistent with what we got for the period. So the asymptotes are going to be at plus or minus, x equals plus or minus 3 pi over 2. Okay, if you don't explicitly write x equals for the asymptotes, it's 0 credit. Okay? 0 credit. I'm telling you now, this is Precalc Honors. Welcome to Precalculus Honors. Asymptotes are lines, so you need equations of lines. Okay? You can't get an equation without a variable. All right. Now, because it's symmetric, negative 3 pi over 2 to 3 pi over 2, I know it's going to be centered evenly around the origin. So I have negative 3 pi over 2, 3 pi over 2. The midpoint is 0, and then we have negative and positive 3 pi over 4 on either side. Now, I put my asymptotes here. Remember, the asymptotes were derived from the definition of tangent. Tangent is defined as sine over cosine. So this is from the definition. So if you don't have the asymptotes in your graph, that means you've not drawn a tangent. Okay? By definition, what you've drawn is wrong. Okay? At 0, it's 0, because tangent of 0 is always 0. The right-hand side corresponds to quadrant 1. Over there, tangent is positive. And because my a value is 1, I go up to 1. On the left-hand side, it corresponds with quadrant 4. And tangent is negative there. And because a is 1, it's negative 1. Negative 3 pi over 2. But when you put 3 pi over 2 into 1 over 3 times x into the equation, okay? Yeah. Okay? Okay. The period for this next one is how much? 4 pi.
But it's negative, so it's the
Okay,
opposite.
right, hang on. Shh. We're going to go from negative pi over 2 to pi over 2. So this is going to go from negative 2 pi to 2 pi. Distance of 4 pi again. So the asymptote is x equals plus or minus 2 pi.
Yeah, because we finished the last lesson in one day. So.
Everybody is on the same track. We're not ahead. Okay? Okay. Now, we're going to go from negative 2 pi to 2 pi. Okay, I have asymptotes here. At 0, tangent of x over 4 is 0. Now, watch up here for a minute. At pi, we would have gone up to 1, but there is a negative in front, so I go down to negative 1. To the right, I'm going to go up 1, the opposite. Okay? All right? Now, let's do one with a phase shift. The The period is what? Just pi because b is equal to 1, right? Okay, the phase shift, we're going to do x plus pi over 2 is equal to 0, just like we did before. So x equals negative pi over 2. Now, asymptotes. It's what we were doing in sine and cosine. We're going to solve this inequality. So we're going to go negative pi x to 0. Okay? Now, asymptotes then are at x equals negative pi, x equals 0. All right, so if this is x equals 0, here's negative pi. 1, 2, 3, 4, we're at 0. Okay, asymptote. I have an asymptote at negative pi. I have an asymptote at x equals 0. You can put it right next to the y-axis in order for it to be visible, but make sure it's visible. Okay, listen, the rest is the same. At the center is always 0. Now, this has a negative in front. So to the right, it's negative 1. To the left, it's positive 1.
You're not going to state what the points in between negative pi and 0?
Huh? We do. That's what I'm going to do now.
Oh, so we would need to do that.
Yeah. Okay. Now, negative 3 pi over 4. Now, let's do cotangent. Cotangent is cosine over sine. So it's undefined whenever sine of x is 0. And remember, sine of x is 0 when x is 0, pi, 2 pi, and also negative pi, negative 2 pi, and so on. At those points, it has vertical asymptotes. So, because we hit an asymptote at 0 and then another one at pi, cotangent goes from 0 to pi. Okay? Period is pi one more time. Tangent and cotangent are similar, with the exception that tangent goes from negative pi over 2 to pi over 2, cotangent 0 to pi, and it looks like it's the it's the reflected version. So it's positive on the left, negative on the right. So it looks like a negative tangent.
With the phase shift.
Right. So now, remember, in the region between 0 and pi over 2, what quadrant are we in? Between 0 and pi over 2, what quadrant? Quadrant 1. Cotangent is positive there. In the region between pi over 2 and pi, what quadrant are we in? 2. Cotangent is negative there. Okay? Right, right. But for different reasons. So, the asymptotes again are at 0 and pi. So basically what you need to take away from that is this is the equation we're solving now, the inequality. Except they are just inequalities. Okay. Now, let's do cotangent 2x. The period is pi over 2. Okay. Asymptotes. So we're going to go 0, 2x, pi. So it's going to be from 0 to x to pi over 2. So asymptotes are at x equals 0, x equals pi over 2. All right. We're going from 0 to pi over 2. So 0, 1, 2, 3, pi over 2. In the middle, it's pi over 4. Okay? What is it before then? Okay, pi over 8, 3 pi over 8. Asymptote at 0, pi over 2. Cotangent is 0 in the middle. Okay, and then to the left, it's going to be positive. To the right, it's going to be -1. Looks like that.
If we do multiple periods, can we do it like it's shown in
Yeah, we'll just do another one. Yeah. Huh?
so, but like what we don't have to put
Secant and cosecant. Remember, cosecant is 1 over sine. That means it has asymptotes when sine of x is 0. And then cosecant has minima when sine has maxima, so they're reversed. When one has a minimum, the other one has a maximum. Yeah. Secant is 1 over cosine. Secant has asymptotes when cosine equals 0. So here's how we graph secant and cosecant. For cosecant, we graph a sine function. So do you see down here? This is a sine function. So I graph my sine function. And then I just go in and I put in asymptotes wherever the sine hits the x-axis. So asymptote, 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 asymptote. And then in the middle of the asymptote, I do the use. One more time. Listen. Let's go up, let go of the anxiety. Listen. We all know how to draw a sine graph. Draw a sine graph. Okay. Hits the x-axis, asymptote. Hits the x-axis, asymptote. Hits the x-axis, asymptote. And then you use. Cosine. We all know how to draw a cosine. Hits the x-axis, asymptote. Hits the x-axis, asymptote. You. Okay. The difference is the graph of the secant and the graph of the cosecant is just that green part without the stuff in the middle. So it's empty in the middle. All right.
we can draw our sine cosine graphs listing
Yes, let's, yeah. The period for both is 2 pi. Okay? All right, let's just do this one. We're going to graph 2 cosecant 2x. First, period. 2 pi over 2, which is pi. Now, let's let go of the asymptotes for a minute. For the cosecant, I draw a sine function. That was nice. I already did it for you. You just draw y equals sine of, 2 sine 2x. Now, here, it hits the x-axis. I put an asymptote. Another asymptote there. Another asymptote there. Okay? Now, let's draw our u's. Yeah, I am. Okay?
no point, right?
The purple, no points. The purple is the cosecant graph. Now, the asymptotes are at x equals 0, x equals pi over 2, x equals pi. I'm just reading it off of the graph. No, just do the one. I just did that one for fun. Just do the one from 0 to, like, just do this one.
Oh, so we don't need it.
Yeah. It's, no, I want to take points off. Yeah.
The cosecant graph It touches, correct?
It has to touch. It has to touch at the maximum and the minimum. All right? It's got to touch.
Okay.
Now, let's do this next one. Negative secant 2x. The period again is pi. Okay? Now I need to draw a negative cosine 2x. Okay? What I'm going to do is I'm going to make this a 2 and this a minus 2 so it's not a tiny little graph just to give me more space. Okay, so now look at what we're going to do. We're going to go to pi. So from here, 1, 2, 3, 4. This is pi over 2. And now look, I'm also going to do the left side, and I'll show you why. I'll fill in the other points in a minute. Let me now draw a cosine. Is that a cosine? That, I thought. It's a cosine, but I need a negative cosine. Hang on. I need a negative cosine, though.
It's supposed to start at 1? No. But, it's...
Sorry, hang on. I meant to make that a 1. Okay, so here. Okay, cosine. Now look. If you were just drawing cosine, this would be okay with me. Because we're doing secant, I'm just going to mirror this on the left side. Just continue. Do a mirror on the left side. I'll tell you now. Okay. Now let's do asymptotes. I have an asymptote here. And here. And here. No, sorry, I missed one. Here. Okay? Does that look right? Now, cosecant here and here. I'm sorry, secant. I can't answer 2 questions at the same time. All right. So the reason why I mimicked it on the left-hand side is because had I not done that, I would have gotten a full U here, but this would only have been a half U, and then I would have had to do another half U there, and that's just like cut up pieces of a graph. You want to make it so that you get a full U and a full U. So remember that just for the secant, just mimic on the other side, okay? Go 2 periods and then do your U. Now, if you were on a roll and did another one there, am I going to take points off? No. All right? At least give me the ones here. So let me just write down the asymptotes and then I'll take questions. Asymptote is x equals negative pi over 2. X equals, I'm sorry, no, negative pi over 4. X equals pi over 4, and x equals 3 pi over 4.
You need to write all the asymptotes because...
You need to write those 3.
Those
Okay.
Because